Let me show you the query rewrite procedure. Let's execute the query that runs low with predicate 3058. Grid results, include actual execution plan, and let's execute this query. The query is slow, 260 milliseconds. Let's look at the execution plan. Clustered index seek, sort, and select. Let's move the cursor on top of the sort. There you see the estimated row size is 2015. My goal is to increase the estimated row size so SQL Server can sort in memory. How can I do that? Oh, I have an idea. Let's introduce a compute scala. Let's modify the query. Let's convert our column C3 to varchar 2000. Let's execute this query. The query is still slow. Elapsed time is 243 milliseconds. Let's look at the execution plan. Oh, there is our compute scala. Let's move the cursor on top of the compute scala. There you see the estimated row size is 1019 bytes. Similar to our varchar table. You know, since we converted C3 into varchar, SQL estimates half the amount of memory, and the sort operator estimated row size is also 1019. The query is slow. I am not happy. Let's change the varchar to 4000. Let's execute this query. The query is still slow. Let's inspect the execution plan. Let's move the cursor on top of the compute scala. Estimated row size 2019. Sort operator estimated row size is 2019. Slightly higher. It's not 2015, it's 2019, but still the query is running slow. I am not happy. Let's change the varchar to 4500. Let's execute the query. Wow, the query is fast. Ladies and gentlemen, we made SQL Server fly. Let's inspect the execution plan. Let's move the cursor on top of the compute scala. There you see, estimated row size is 2269 bytes, and sort operator takes over this estimated row size of 2269 bytes. This gives enough amount of memory so the sort does not spill to 10 dB. Well, we should not overestimate the amount of memory. Let's change varchar to varchar 4200. Let's execute this query. The query is fast. Let's change the varchar to varchar 4100. Let's execute the query. The query is slow. So varchar 4200 seems to be good enough that SQL Server makes the sort happen in memory, taking just 14 milliseconds. Well, we should not overestimate the memory. I will not spend the time here to find the perfect number for varchar between 4100 and 4200. I will leave it to you as a homework. Yes, we are back at school. This is what learning is all about. We have solved the issue. Actually, almost. There is still one case this sort can misbehave. Yes, misbehave. We all want full control over our production server performance. Yes, I do not want anything to misbehave. This webcast is going too long already. I think we have to cover the missing link in a future webcast. Let's solve this issue in a different angle. Let's say I am not a developer but a database administrator, a DBA. How do I address this issue? I have no access to the source code to change the query. Yes, I will show you. You will see it. I do not teach undocumented commands in my workshops, but there are trainings where the instructor teaches undocumented commands, stuff like dpcc int, dpcc page, and various page formats and so on. The problem here is these are undocumented commands. You cannot use them in a production server. And if I do use these undocumented commands, in my production server, and for some reason the server goes down or it introduces corruption, I know I will be fired. If I had a choice, I will learn about performance monitoring, tuning and troubleshooting, database recovery planning. Let me tell you, there are people who have an addiction for undocumented commands. Personally, I will not spend my time specializing these undocumented commands, hoping one day the database will become corrupt and I will be the star among my competitive colleagues in my company known for recovering the corrupt database. For an argument's sake, even if the database becomes corrupt with possibility of data loss, you know the chances for corruption is rare compared to day-to-day performance issues. For an argument's sake, let's say the database does become corrupt. I personally would be hesitant to repair with data loss myself because my colleagues will always suspect that maybe a better expert than me would have recovered that database without data loss. Instead, I will go to my manager and tell him or her that the best way to recover the corrupt database is to call Microsoft support. Microsoft support has the best knowledge in the whole world. They have the source code and they know the page formats of various versions and service packs of SQL Server, and they are waiting to support you 24/7. Personally, I have MSDN subscription and it comes with certain number of support calls. I am saving it. One day I will call Microsoft support when my database is corrupt, and I trust Microsoft support. Back to the question, I am no developer but a database administrator, a DBA. Without access to the source code of the application, how do I address this issue? Simply alter the table and change the data type to varchar 4300. Let's see an example. Here is a query that selects from our table 7 with predicate less than 3057 ordered by C2. We know this query is fast. Let's set statistics time on and let's execute this query. This query takes 120 milliseconds, 121 milliseconds, 140 milliseconds. So anywhere between 115 and 140 milliseconds. Let's change the predicate to 3058. Let's execute this query. This query takes 262 milliseconds, 266, 256. So the query takes anywhere between 256 and 266 milliseconds. Now let's alter the table and change the column C3 to varchar 4300. Let's execute this query. It will take quite some time because we got 200,000 rows in this table, and all of these rows needs to be updated. Now let's execute our query. With predicate 3058, the performance dropped to 126 milliseconds, in line with predicate 3057. There is no need to change the query, just the schema, and we can see the performance gain. When developers are not doing their jobs, DBA should take control. I can help both developers and DBAs to better understand and tune SQL Server. I would like to warn those who like to use varchar 8000 for everything, I mean liberally. This is an abuse of memory. Don't overestimate the row size too much. Others might have to pay a penalty. It is not a monopoly game. My name is Ramesh Meyapan. I specialize in SQL Server performance monitoring, tuning and troubleshooting. After short assignments at Oracle Corporation and at Sybase, I worked at Microsoft Corporation from 1994 to 2004. In those 10 years, nearly half of that time, I worked in Redmond in the development teams, specifically as program manager in the Microsoft SQL Server development team responsible for optimizing SQL Server product for SAP. Later at Microsoft Austria, I worked as principal and architectural consultant for Microsoft Consulting Services, helping European Microsoft and SAP customers with Microsoft SQL Server performance monitoring, tuning and troubleshooting, and delivering workshops. Now I offer workshops and consulting services independently as well as by partnering with various Microsoft subsidiaries. I conduct the 3-day level 400, truly level 400 SQL Server performance monitoring, tuning and troubleshooting workshop. You can find my schedule at SQLWorkshops.com/schedule. SQL Workshops with S in the end. Think about it. I deliver the content of this workshop with hands-on, commercial free in half an hour in my workshop. You know, once you are in my workshop, I don't need to promote my workshop to you anymore. That's what I mean by commercial free. Think about it. How will you feel if you got 3 days of such rich content, minimal PowerPoint bullets, pure hands-on? You can see the past workshop participant feedbacks at SQLWorkshops.com/feedbacks. I have 6 days of fresh content and choose and deliver the best in 3 days. I do not cover basics like cluster, heap and non-cluster indexes, database engine tuning advisor or profiler. You won't feel bored and it will have a great impact on your career. My workshop is not a result of reading books or attending other trainings. It is a result of real-world consulting engagements. Ladies and gentlemen, thanks for your time. And wait, I have a challenge, a puzzle for you that you have to solve for your continued learning. We will get to that in a minute. If you like this webcast, send me an email. If you like additional topics to be covered in the performance monitoring and tuning area, send me an email. I will not webcast the entire content of my 3-day level 400 workshop for business profitability reasons. If you want it all, you have to attend the workshop in person. Again, if you like this webcast, pass on the link to your friendly colleagues. Do not point it to your competitive colleagues. What do I mean by competitive colleagues? You know those colleagues sitting next to you and always taking credit for yours and your group's achievement? The colleague who oddly contributes but wants to become the next group manager, you don't need to share the link to this webcast with them and they have to find their own way. If you got this link from a friendly colleague, thank them. This shows that they care about you. I will tell you openly, I do not train my competitors. You know other instructors who conduct trainings who are my competitors, I do not train them. Again, for business profitability reasons, they have to find their own way. Currently, I am planning additional webcasts to cover some topics related to SQL Server performance monitoring and tuning. Actually, most of it depends on your feedback. All my webcasts, like workshops, is related to performance monitoring and tuning, and I assure you it won't be a repeat of what you already know and it will not be boring. Now to the challenge. Let's improve the performance of the query without any predicate. Let me create the table 7 with 50,000 rows. The reason I decrease the number of rows is to reduce the query execution time. Now let's execute a query without any predicate. Just order by C2. Let's set statistics time on. Let's execute this query. The query takes 4 seconds. Now let's apply our workaround. Varchar 4500 convert varchar 4500. Let's execute the query. The query is still slow. Let's inspect the execution plan. Include actual execution plan. Let's execute the query. Let's look at the execution plan. Compute scalar happens after the sort In the previous case, we used compute scalar to inflate the row size, so sort occurs in memory. In this case, SQL Server does the sort first and then converts our column, so the sort doesn't get enough amount of memory to perform in-memory sort. Let's add a fake column to the order by. Let's cut and paste the C3 in the order by, and let's see if SQL Server performs the compute scalar first and then the sort. The query is still slow. SQL Server does the compute scalar after the sort. Let's trick a little bit. Let's add an empty string to our convert. Let's execute this query. You see, the query is fast. It did not take 4 seconds. It took 570 milliseconds. And when you look into the execution plan, the compute scalar happens before the sort, inflating the row size. So the sort has enough memory so it does not spill to 10 dB, and our query is nearly 8 times faster. Ladies and gentlemen, there might be challenges on the way, but if you know what you want, you can find a way. I would like to ask you a favor. If you notice other trainers, instructors, or speakers using these examples and concepts, ask them to give credit to SQLWorkshops.com by mentioning SQLWorkshops.com website link in their speeches and materials. Tell them if they use the above ideas and concepts, simply copy, reuse without giving credit. People at SQLWorkshops.com will not be motivated to deliver future SQL Server webcasts, and it will be a loss for the community. We at SQLWorkshops.com thank you in advance for your help. Back to the challenge. Let's execute our top query. Let's set statistics time on. Let's go to the text results and let's execute with top 100. Let's execute the query. It takes 168 milliseconds, 192 milliseconds. The query is quite fast. Let's change to top 101. Let's execute this query. This query is slow, taking 1.3 seconds, 1.4 seconds. Now let's apply our workaround. Let's convert our character column to varchar column. Let's execute the query. The query is fast. Ladies and gentlemen, by changing the data type to char to varchar and inflating the row size, we make the top 101 query perform as good as top 100. Your challenge is to tune this query on SQL Server 2005. Let's cut and paste the table creation script and connect to SQL Server 2005 instance. Let's go to the test database. Let's make a new query window. Let's make sure we are on SQL Server 2005. Let's paste the table creation script and let's create the table. Now let's execute our top query on SQL Server 2005. Let's make sure we are actually connected to SQL Server 2005 test database. Yes. Let's set statistics time on and let's execute top 100. Let's go to the text results. Let's execute it again. 164, 167 milliseconds. Now let's change to top 1. Let's execute the query. The query is slow. It is not 167 milliseconds. It seems to take many seconds. In SQL Server 2008, this query takes 1.3 seconds. Here, in SQL Server 2005, it takes 15 seconds. Let's execute the query again. So it takes around 15 seconds. Let's apply our workaround. The query takes 15 seconds. Let's apply the same workaround we applied in SQL 2008. Let's cut and paste this workaround over here and let's execute this query. to see if our workaround also applies to SQL Server 2005. It doesn't look like the query is executing fast. It's taking 14.8 seconds. Ladies and gentlemen, I recommend you to upgrade to SQL Server 2008 and apply our workaround. In case you can't upgrade for some remote reason, take this as a challenge and find a way to tweak the query, to rewrite the query to make it faster. Do not listen to the so-called experts and buy additional hardware or software to solve this issue. Even if you place 10 DB on SSDs, solid-state disks, SQL Server has to deal with the overhead of creating data structure to spill the sort over 10 DB, like creating work table and issuing IO requests. With in-memory sort, you have no such overhead. Surely this is faster than any SSD, solid-state disk-based solutions. I suggest you to solve it by rewriting the query, by helping the optimizer, SQL Server, do in-memory sort. In order to motivate you, to get you going, I will show this undercover. I will rewrite the query, tweak the query under the cover of Task Manager. Let me select this query, go to a new query window, make sure we are in SQL 2005. Yes, let's set statistics time on. Let's choose text results. Let's execute this query. Let's bring the output window below. Let's bring the from class all the way to the bottom so you can see it while I rewrite this query. So the query took 15.5 seconds. The query returned 101 row because we have top 101. What I am going to do is place the task manager on the top so you can see I do not change the from clause or the where clause or the order by. Let me start my query rewrite procedure. Let me execute the query. There you can see the query took 244 milliseconds and it returned 101 rows. So I did not change the top, order by, from, and where clause are the same. The query is more than 60 times faster, 6,000% faster. You are wondering why I am saying 6,000% instead of simply saying 60 times. You know those marketing people, the third-party software and hardware companies, they like to say those numbers, 3,000% faster, 4,000% faster. It looks attractive. Do not buy that. You can make it 6,000% faster without their help. It is time to give credits. I would like to thank Peter Hussey, the best manager I ever had. Peter, thanks for hiring me into the SQL Server development group at Microsoft and for giving me the responsibilities and trusting me and for giving me the confidence I needed. I would like to thank Gudmundur Karlsson. We call him Goodman. When I was a program manager responsible for SAP SQL Server integration at Microsoft, Goodman, the SQL developer in the SAP porting team, used to report bugs to me. In many occasions, even before the bugs were fixed, Goodman would continue his development by finding workaround for those bugs. In a way, his approach has been a motivator for me, even today, to find a workaround, to solve the customer's issue on a timely manner. And last but not least, I have to thank Microsoft for giving me the opportunity to work with great teams, for giving me the opportunity to develop deep SQL Server knowledge, and of course, for securing my retirement financially with stock options. At SQLWorkshops.com, our mission is to empower customers to fully realize the performance potential of Microsoft SQL Server and achieve high customer satisfaction in every consulting engagement and workshop delivery. If you want to engage us for troubleshooting your SQL Server performance issue, let us know. Our consulting rates are very reasonable. If you want to attend our workshops, let us know. Our workshop rates are slightly higher than the industry average. But I can assure you, we deliver the best of the best. In case you plan an on-site workshop, we offer up to 50% discount. At SQLWebcast1Part3of3, we are standing by to help you succeed. If you are interested and want to be notified when we release the next webcast, which should occur in a couple of weeks, please send your email address to me at rmayappan@SQLWorkshops.com. I will send you an email when we are ready with the next webcast. Due to limited network bandwidth available to us, we might restrict the number of downloads. So we encourage you to send your email address to us for notification. If you are happy with this webcast and like to contribute to our network bandwidth expense, you can donate 5 euros. You will find the PayPal donate button in the download page. Our goal is not to make a huge profit out of these contributions, but to cover our network bandwidth cost, which is unusually high due to the length and the size of the webcast, and your help will be appreciated. We suggest 5 euros. The reason is we want to make the contribution small enough that you can pay out of your personal expense rather than filing paperwork and waiting for approval from your manager or employer. We plan not to take sponsorship from third-party software or hardware companies because we want to stay independent and neutral without being partial to certain third-party software or hardware companies obligated to promote their products. Ladies and gentlemen, thanks again. It was my pleasure delivering this webcast to you. I look forward to your feedback and wish to speak to you in the next webcast. Until then, bye.